Okay, I'm recording now. And so this is the Taiwan Hub project pitch, part 3 for the remaining few, some of the students who were not able to make it for the previous 2 pitches, project pitches. So we have, this is the 3rd one now. And I think on the schedule, I was told the first one will be Li-Xuan, right? So Li-Xuan, if you could share your screen and check if your microphone and everything is working. Can you say something? We'll just make check that we can hear you. If you're speaking, I can't hear you. So no sound. Or is it me? Hang on.
Hello.
Yep. Now I hear you.
Can you hear me? Okay.
Yeah. Now I hear you.
Sorry. I'm
Okay.
figuring out the settings. Sorry.
Yeah, no, I know. It's new to me also. So
Okay.
can you share your screen?
Okay, I'm going to share my screen.
Okay, good. I see it.
Okay.
Okay, so whenever you're ready, please go ahead and start.
Okay. So thanks for you all coming, and sorry for the inconvenience of the rescheduling. And first of all, I want to thank Professor Kevin to giving me this opportunity to attend this BrainHack School. Although I'm not belong to Institute of Neuroscience, and I'm Alex from undergrad in IPECS, that is interdisciplinary program of PECS in National Central University. And I have a strong interest in neuroscience related topics, so I chose this courses. And thanks Professor Kevin gave me this opportunity. And for my pitch today, my project is detecting AD-caused atrophy via SAM-based adaptations and fine-tuning on structural MRI images. I want to give a brief background introduction to the SAM. SAM is called, the full name is Segment Anything Model that is released last month by Facebook AI Research. And this model is aimed to segment the semantics of arbitrary images. This is a concept called foundation models that it is a data-centric AI models that train on extensive data, various data, and various modalities. So this foundational models has some abilities to generalize on various topics. And there's another team from University of Toronto, also last month released adaptation of these foundation models on the medical images. That is called MEDS-SAM, which will be mentioned in the next slides. Here are the snapshot of the papers, and as you can see here, there are ground truths. The left columns are the ground truth of tissue segmentation, and the middle column is directly from the foundation models. That is no training on the medical images. And the rightmost one is the MED-SAM. This model is fine-tuning on medical images. As you can see here, the medical SAM has a good performance on segmenting some tissues from the MRI images. So I want to use this kind of techniques to fine-tune and then to adapt this to the downstream text such as AD-caused atrophy. So the specific aim is like I want to detecting AD-caused atrophy on brain structural MRI images, perhaps to help pathologists efficiently spot the risk in early diagnosis. And the methodology I want to use is adapting foundation models like we previously mentioned SAM and MED-SAM to domain-specific tasks. detecting atrophy area via bounding boxes, anchors, or even text-based prompts, which I will show a conceptual demo in the next slide. Okay, and producing pixel-level segmentation masks to spot the area that we're interested. The data set I want to use is, although it is still in the explanatory data analysis and organizing, since there are various data formats, so I need to organize it to best suit the model input. So while avoiding potential biases. So the data set I will choose is those three. And the first one is from OpenNeural, and the second and third one are from Kaggle. But there are some problems about the first is the quantity of the data are relatively small. So, and comes with different modalities or dimensions. Like the first one is a 4D scan data, and it contains 3D ball cells and one-dimensional gradients. Okay, so the second one and third one are comes with 2D slices only. So there are some conundrums I want to maybe I will face. So yeah, the first one is inadequate segmentation ground truth. Like the first slide, it has a very complete data sets, but due to some ethics problems, we don't have such a complete data, so we need to find some open data. So maybe the inadequate segmentation ground truth data will limit the performance of fine-tuning on this specific task. And the second one is inadequate computation resource. Because I haven't tried this model in my workstations, but there's a potential risk that out of the RAM, out of the vision RAM, so I can run the model. But I will try my best to solve this problem. Yeah, okay. And the third one is different data dimensions will affect fine-tuning techniques to be performed, because that, as I mentioned before, there are various standards. Like the first one is follow the BIDS rules, but the rest of these two are not only 2D slices. So there are two different ways to solve this. First one is to do more extensive survey on this relative data sets, and the second one is change the task, because there are more occasions is there are more extensive data on the brain tumor segmentations. So if I can found adequate data on AD related atrophy data, maybe I'll change the task to brain tumor segmentation. But my original motivation is that one of my aunt has suffering from AD, so maybe that is a motivation that I want to pursue this kind of diagnosis through the most advanced deep learning techniques. And that is my pitch today. And here are the keywords. And for the techniques, I have provided the link to the paper and the core repository. So you can, if you feel interested, you can just click and directly to the original paper. Okay. So here are a quick conceptual demo from the meta. So here I prepare a MRI 2D slices and input to segment anything. And this version is without any medical data fine-tuning. So this is only the segment anything original model. But as you can see, I can just draw a box here, and you will just segment an area for me. So even you can cut out some area. So that is pretty cool. It's especially it is unforeseen any of the medical images on this model, but it can generalize to recognize the area and segment it to us. So this is very powerful. So if we fine tuning on the specific task, it will perform better rather than building bottom up from sketch. So performance will be better. And that is also the trend on recent deep learning research. That is use the foundation models on the downstream text. Okay, so that is my pitch today. Okay, I wonder if you have any questions. Thanks.
Okay, thank you very much, Li-Xuan. I'll take over as a host for now. So sorry that I came in halfway. So are you going to use all three database for your project?
Okay. I was actually considering right now because as I mentioned before, there are different modalities, but for the convenience and the computational cost considerations, I will do mainly focus on 2D slices instead of 3D one. So maybe these two or the other in my future survey, I will mainly focus on 2D slices with this kind of atrophy.
Okay, thank you. Well, this is really impressive. I mean, previously we were still learning to learn. We were told that structural tracing had to be done manually because there are some ambiguous cases that can only be judged correctly by human eyes. But it seems that machine learning has now brought us to a different level. So yeah, I look forward to your project.
This research is actually released a month ago, so it's very latest one. But I found it really interesting in the downstream text. Yeah. Yeah, because they are dealing with more generalized case. Like the wide area of the tissues, but not for some specific disease or the degradation here.
Okay, thank you.
Thank you.
Do we have questions from the audience?
Yeah, I'm curious about that. Does the data has some like behavioral data from the subject, like they have any problem in either language or memory, or do they also provide some like MMSE score or other diagnostic information? Does that come with the data set?
Okay, that is a huge problem because the first data set it provides some I will say I don't know how to say it as temporal lobe atrophy. The first one is about temporal lobe atrophy, and the second one and third one, it only provides us some classifications on the mild ones or moderate ones or very slightly moderate ones. So I think that there's another thing about this technique is that it could perform we call zero-shot learning. That is, even if you don't give a lot of labeled data, it could learn something from the unlabeled data. So that is one of the magical behavior of those kind of foundation models. So, but I can't validate. So I can't validate the parameters. Sorry.
That's okay.
But yeah, but it could learn from those unlabeled data and give you some results. And maybe you can just scrutinations do some scrutinations on these results by the pathologists. Yeah.
Okay. I think really looking forward to see the results. Okay. Yeah.
Thanks.
Do not have further questions. Yeah.
Thanks.
Can I ask who are you gonna work alone, and who is your TA?
My TA is Ray.
Oh,
It's
okay.
me. Yeah.
Yeah,
Okay.
and I will do this alone. Yeah, but I'm open to everyone who is interested in this project. So if anyone like interested in this project, I will very happy to collaborate with. Yeah.
That's awesome. So if after this, if you create a post in the project 2023 channel, perhaps you can recruit some teammates who can work with you together on this.
Okay.
I mean,
Let's see.
international teammates. All right. Okay. Due to the interest of the time, let's move on to the next one.
Sorry. Okay.
Rong-Xuan. Thank you, Li-Xuan, for the very interesting presentation. Okay, Rong-Xuan, go ahead. Can you share your screen?
Okay. Can you see my screen?
No.
No.
Okay.
Okay.
Yeah, I can see your screen now.
Good afternoon. My name is Rong-Xuan, and my project page is on grasp and live EEG detection. I'm a junior student from NCU CSIE. Long-term imagery is a crucial application method of brain-computer interface. So it's important to understand the relationship between hand motion and EEG signals. So the dataset I use in this project is obtained from Cargo. The dataset is from 12 subjects. There is 10 series of trials for each subject and approximately 30 trials within each series. During the experiments, the participants are instructed to grasp and lift the object, and the EEG data is labeled with 6 motion phases. The first one is the hand starts to reach a small object and grasping it by using the index finger and the thumb. Then lift it in a few centimeters into the air and holding it stably for a few seconds. And in the end, we will replacing the object to the table and releasing the object. So the specific aim is to classify the 6 different phases accurately. For the method and tools, I plan to use machine learning or deep learning model to analyze the data, and probably use the optimization algorithms to fine-tune the parameters. I aim for achieving at least 80% accuracy for the classification results. Why I choose this topic is because I'm interested in brain-computer interface, and I have known or heard some common methods that use in BCI signal analysis from other classes, but I have not yet completed a project using this method, like SBM, CNN, or some mathematic method for signal processing, or fuzzy model, and so on. So through this project, I hope to acquire the practical experience and skills to applying this technique. Thank you for your listen.
Okay, great. So just a quick question. So the 6 phases has been labeled in your data set?
Yes.
Oh, okay, cool. Yeah, I think this is really interesting and then really can have a lot of applicational implication for BCI. Any questions from the audience?
Yeah, I just has a quick question. So from the goggles, so yeah, I just wonder what's the accuracy score of the benchmark model, and how is firstly what is the highest score on their board? Yeah.
The highest score is almost 100%
Okay. Okay. Cool. Yeah, I think it'll be very interesting to see how you can use a different approach to attack this problem. Yeah.
Cool. And so please also create a post here so that we can continue the discussions over there. And I think really this is really interesting. So I think you'll get a lot of discussions there. So let's move on to the last one, Ting-Hsin.
Okay. I will share my screen now. Can everyone see my screen?
Yep.
Okay. Hi, I'm Ting-Hsin, and I'm from National Central University. I'm currently a second-year master's student, and my project topic will be using a syntactical surprisal that was calculated by Ngram model to use as a predictor to in English as second language learner speech comprehension analysis. So the reason why I wanted to use the syntactical surprisal as the predictor is because in a past research, we know kind of like there's a debate between how do we understand not only the native speaker or also the second language learners, how do we comprehend language? There's the debate between like we understand word by word, or if we use like syntax or some grammar rules to understand the speech. So the syntactic surprisal will be the probability of the words, how do I say? The probability of the target word of its part of speech, which is the category of the words, and which will represents as the grammar concept here. So that we use this syntactic surprisal to use as a predictor by to see whether the second language learner comprehend speech using these kind of grammar rules or syntax elements. So the analysis will be a temporal response function, which is the estimated brain response that was elicited by the stimuli, and that which was calculated by a linear convolutional model. And the syntactic surprisal will be calculated by a trigram model, which is all done in Python. And the data set will be the 13 Mandarin speakers who are English as second language learners that was collected in my lab, in our lab. Yeah. So, and yeah, that it's for now. Yes.
Okay. I personally am really interested in this project.
Okay.
Just have some quick questions. So
Yeah.
are you going to do the syntactic tagging by yourself, or do you already have a labeled corpus?
I think I will use a labeled corpus, but I will have to look into the corpus. I do have in our lab we do have the COCA corpus, so I will try to see whether they have the tagged POS. Yeah, and then we could calculate the syntactic surprisal real quick.
Oh, okay, okay. And the tagging in your material has all been done already?
No, I have to do it on my own, like using the corpus to as the base to calculate the POS of my material.
Oh, okay.
Yeah.
Okay.
The concept will be like to input my material and then use the POS from the corpus to tag it.
Oh, okay, okay.
Yeah.
Cool. Yeah, and I think this is really interesting because other than just simply like lexical to lexical, like word surprisal, would syntactic surprisal also matters? I think it matters. And yeah,
Some research said it matters, but yeah, some said probably not.
it is controversial.
Yeah.
Yeah. Okay. Any other questions? If no, thank you very much for the very exciting the presentation on these 3 very exciting projects. And I do encourage you to create a post about your projects in the channel. I think so far, I mean, people are will slowly read through the project and hopefully you will get more comments there. All right, so any comments? If not, then let's just wrap up. And I think next, I mean, we are hoping to do some social activities in the next or the next week from now. I think in the second half of the BrainHack School. So hopefully we can have more time to hang out with each other. All right. Okay, so thank you all. And should I